السلام عليكم ورحمة الله وبركاته. أهلا بكم أبنائي وبناتي طلاب الصف الثاني الثانوي. نرحب بكم مع منصة البث المباشر وزارة التربية والتعليم جمهورية مصر العربية مع Chemistry Sessions. We start in this session nuclear chemistry. What the meaning of nuclear chemistry and which study in this session? We will start by the concepts of the nuclear chemistry. Nuclear chemistry interested on the structure of the nucleus and the components of the nucleus. If you find the nucleus in the center of the atom consists of two components. Number one, nucleus. Number two, electrons. So nucleus have positive charge. This positive charge is protons, and neutral charge, or sorry, neutral particles is neutrons. So, and scientist Henry, this scientist discuss the in 1896, the scientist Henry, this scientist discovered coincidentally, with the meaning of coincidentally, a type of invisible radiations. These invisible radiations emitted from one of uranium. These uranium compounds causing the formation of shadow on a photographic uranium compounds, and he called this phenomenon radioactivity. I mean here for these scientists, radioactivity, I have many elements, radioactive elements. These elements radiate invisible radiations. So you can see these radiations, but you can't detect it by using a photographic film or another devices. You can't use these coins photographic in this photographic film and envelopes. Okay, this is found here in the photographic films after transmitted. I have the radiations. These radiations you can't detect it by using the photographic. So the scientist Henry used that. Scientist Henry used that to indicate these radiations. Why use uranium compounds? Because uranium is radioactive elements. In 1932, the scientist James Chadwick. James in 1932, this scientist discovered that atomic nucleus, okay, contains a neutrally particles. Because the book calls neutrally charged particles. So I have no charge here. I have a particle. This particle is no charge. What the meaning of neutral charge? Neutral charge is equal to no charge. Okay, so neutron is neutral particles called neutrons. The summation of protons and neutrons inside the nucleus is called mass number A, or the number of the nucleons. I mean nucleons, okay? Nucleons, this is the summations of neutrons and the other particles like protons. I told this before, taken in the last stage in your studying. Now, I will describe of atomic nucleus. I have the A, Z, N, which these symbols, I mean this symbol A is the mass number, or mass, or atomic mass, or the number of nucleons inside the nucleus. So this A equal summation protons and neutrons. So number of protons plus number of neutrons equal to A. A means the mass number. So I have atomic number Z. Z, number of electrons in the neutral atom. Number of neutrons is N capital. So N equal to A minus Z. So you learn that before when you teach it, when you learn the structure of atomic in the first year in the last stage. Now you can write X. X is a central atom or is the atom you teach it. Or you can't learn any atoms. You write A here, A in this position, Z in this position. You can write N in this position. Now A it is the atomic mass. Z is the uh, number of protons inside the nucleus or number of electrons around the nucleus. So any atom is neutral particles. Number of protons equal to number of electrons. So representations of elements, any elements can be represented as A, the mass number, Z is the atomic number, X is the element symbol. So you to know Eric, the scientist Enrico Fermi in 1942, Enrico Fermi directed the first controlled artificial nuclear chain reaction. What the meaning of nuclear chain? Now we know I have nuclear or nuclear emitted or radiation emitted from any radioactive elements. So this scientists control artificial induced nuclear chains reaction. Since then, research and studied in the nuclear chemistry continued extensively. So worked in this things. You can write that for any atom. So what is the nucleus symbol of cesium atom? That contains 55 protons and 78 neutrons. Okay, I want to write that. So atomic number of Z equal to 5. A number of protons equal to 55. So the mass number equal to number of protons and number of neutrons. So you can do sum 55 plus 78 equal to 133. You can write CS in the under here is 55 and in the top is 133. Okay, you can to transfer for another idea to write some questions and you make feedback for the last explanations. Now write a nuclear symbol of an atom containing 17 protons and 18 neutrons. Solution is what? Which Cl? Yes, Cl 17 here. 35, it is the atomic mass. You can't write it by the summation is 17 plus 18. So let's write the nucleus is 1735. So the next, an atom has atomic number 29 and mass number 64. 29 and mass number is 64. Find the number of neutrons. So you can to write the 64 is the atomic mass. You can to make subtracts from 29. Now you can the result you know the results equal to 64 minus 29 equal to 35 neutrons. Now which particles determines the element's identity? The number of protons is the atomic number. The number of nucleus the number, I'm sorry, nucleons is the atomic mass. Which particles this I have if you I'm sorry, if an atom has 12 electrons, how many protons does it have? Okay, neutral atom equal to protons equal to neutrons equal to 12, because any atom is neutral. Any atom is neutral. Now, an atom in nucleus contains 20 neutrons and 19 protons. Identity the elements. Which elements here? I want to know it. Which elements here to know it? Okay, you can teach that for that. Now, an atom's nucleus contains 20 neutrons and 19 protons. 19 protons. Okay, identify the elements. So Z equals 19. This is the atomic number. So this is a potassium. This is a potassium because the atomic number of potassium equal to 19. Now we transfer to another type or another thing you can teach us. Now I have the isotopes. I have isotopes. Which isotopes? What the meaning of isotopes? Isotopes, if you have carbon 612, okay, listen to me, God, 612, and carbon 613, and carbon 614. I called for these carbon is isotopes of carbon. So, what is the difference between C6 12, C6 13, C6 14? I discovered that the difference between them, the mass number. Okay, because the number of neutrons are different. So these are the isotopes. Okay, now carbon 12, carbon 6, 13, carbon 6, 14. The number of neutrons here equals 6, number of neutrons equals 7, number of neutrons equal 8. So isotopes are atom, same elements that have the same atomic number. Now I have 6, 6, 6. They have the same number of protons and the same number of electrons, the same atomic number Z, different mass number A. So the number of neutrons are different between them. Number of neutrons between them are different. So you can write any isotopes you have, like isotopes have the same chemical properties, yeah. Why? Because they have the same number of electrons. Isotopes have different physical properties, yeah, because they have different masses. Now, in isotopes, any isotopes have the symbol like H11, H12, H13. This example of hydrogen isotopes. Hydrogen isotopes like protons, protium, this deuterium, and this is tritium. Hydrogen, 1, 1, 1. Why? They are isotopes because they are different in atomic mass. 1, and here is 2, and here is 3. So number of protons, Z equal to 1. Number of neutrons, 1. No, here 0, no neutrons here. So I have 1 neutrons, I have 2 neutrons. So mass number is 1, 2, 3. Okay, I have another example in this slide. Hydrogen isotopes, I have oxygen isotopes. Okay, it is very easy to know that. Now oxygen 16, 17, 18, they are the same atomic number equal to 8. And neutrons here, 16 minus 8, 8, 16 minus 8, 9, 80, 17 minus 8, 9, 18 minus 8, 10. So the number of protons, they are the same. Number of neutrons, they are different. Number of the nucleons or mass number equal to 16, 17, and 18. Why do isotopes have identical chemical properties? Because they have the same number of electrons. I told it before. Which oxygen isotopes have the greatest mass? 18. I teach it here in this table. Now, 18, it is the largest or the heaviest or the greatest mass number. I want to know the types of isotopes. I have two types. I have stable types or unstable isotopes. Stable isotopes, such isotopes don't emit any radiations. Okay, I repeat it again. If you have an isotopes doesn't emit any radiation, so it is stable because its structure is stable. It is not changing in its structure. But if you have changing in the structure of the nucleus after sometimes, so it's called as unstable isotopes because they emit radiations. Which radiation you have? I have many radiation like alpha, beta, and gamma, and other radiation. So I will know some things about these radiations. Okay, I want an examples for stable isotopes and unstable isotopes. Okay, oxygen 16 isotopes, sodium 23 isotopes. Okay, which 16? 16 is the mass number, 23 is the mass number of sodium. They are stable because they are not emit any radiation. Okay, okay. So I have unstable such uranium 235 isotopes. It radiate radium 228, it radiate, so unstable in its structure. Okay, how many neutrons are found in Xe xenon 54, 134? You can to make subtracts between 131 and 54, so equal to 77 neutrons. Okay, name the isotopes of hydrogen used in nuclear fuel. Deuterium and tritium used in these fuels. Now I have this effects of the electric fields of the radiations on unstable nucleus various shown in these figures. I have this is beta, gamma, alpha. What the difference between them? I have in this plate is positive and this is a negative. So positive will attract for positive attracts for here there's a negative because beta is a negative charge or a negative particles. Okay, I have alpha. Alpha is a positive charge or a positive particle. So gamma, it is a radiation, it's no charge or any mass of it. Okay, you can to make differentiations between them. Type of this radiation, alpha, beta, and gamma. New nature of alpha. Alpha is helium nucleus, helium nucleus. Beta, beta is electron, like electron structure. Gamma is a high energy photons. Okay, alpha it is the property alpha. The property is a nature helium nucleus. Beta is a fast electrons. Gamma is a high energy photons. Which charge of alpha have a positive charge? Positive 2. This is like electrons, so it is a negative 1. So a gamma is no charge. Electric field. This deflections here because it attracts to the negative because it positive charge. So the negative will attract and the deflection towards the negative. Electrons, oh sorry, the beta radiation will deflected in the direction or towards the positive a charge in the electrodes, but the photons doesn't deflect because it's no charge. Okay, the magnetic effect affects not effects because it is no charge and no mass. Okay, I have many questions to make feedback for the last illustrations. Which radiation has no mass and no charge? Gamma rays is no mass and no charge. Which radiation is deviates towards the negative poles? Alpha particle is deviate into the positive, I'm sorry, negative charge because the alpha is a positive charge. Okay, which radiation has the greatest penetrating power? Okay, the penetration depends on the mass. The mass, okay, I have gamma, no mass. So its velocity is very, very, very fast. It is the greatest radiation for the kinetic energy. So the gamma rays is the greatest penetrations power, which gamma rays not affected by magnetic fields because it's no charge. It is no positive charge, no negative charge, so it's not deflected or towards anything. Okay, now you can to discuss that for the illustration of this. Now we transfer for conversion of mass to energy. I have a theory for the conversions between mass and energy and vice versa. Einstein calls energy stored in the any nucleus depends on its mass. When increase the mass of nucleus, so the energy stored in this nucleus is very huge because I make the equation mc square, which you see it is the speed of light. And speed of light is a constant number equal to 3 times 10 power 8 meter per second. So mc square, you must save this law because used to calculate the energy or binding energy or the energy inside the nucleus, or the energy you want to calculate that for the conversions between the mass and the energy. So energy, you can use the unit joule and mass by kilogram. Mass by kilogram. See the speed of light equal to 3 times 10 power 8 meter per second. Alternative force now, electrons, energy equals to m times 931. Why? Because the conversions from AMU to MeV, which is a short for MeV, million electron volts. Now you must know these joule, kilogram, and meter per second, and million electron volts. Now you can know that for this conversions, you can from this conversion of mass estimated in kilogram by applying Einstein equation. If you want to calculate J is joule, energy by joule, you can do multiplications mass by kilogram into 3 times 8 3 times 10 power 8 power 2. Okay, the Einstein from this is Einstein formulate the mathematics equations illustrated the relations between the conversion mass and energy. So we can write it easy for find the energy produced from converting 1 gram of mass into energy. So I want this energy by joule or by calorie or million electron volt. Now I have mass equal to 1 gram, so we can convert it into joule. So 1 times 9 times 10 power 13. You can to apply this calculate of produce energy estimate in million electron volt MeV from the conversions of mass estimated atomic mass unit AMU atomic mass unit. So by using this equation, M times 931 mass times this constant value. Okay, I have 1 million electron volt equal to 1.6 times 10 power negative 13. This is number. You must save these numbers. I have many numbers. You must save it to understand that. The previous relations can be summed up the following diagram. Now, I have this diagram to know the conversions between mass to joule or calorie or million electron volt or atomic mass unit to gram or joule or another. You must save this. You take short screen for this to know the conversions between them. Now, energy in joule equal to this constant value times converted mass n. Okay, this mass by kilogram. In this direction, you make multiply in this number. If you convert it from energy to mass, you must divide it in this number. Okay, if you can atomic mass unit from this, you can do in this direction time in 931 in this direction divided to 931. Convert 50 million electron volt to joule. Okay, 50 times 100, 1.6 times 10 power negative 13. Okay, this is the value. Find mass equivalent of 93.1 million electron volt. The answer is 1.6 times 10 power negative 28 kilogram. Substance X in this, what is the amount of energy which results from the transformation of 0.2 gram of substance X into kilojoule? I have many choices. You must write the law, and you can to apply for this law. Now we have an idea: mass per kilogram equal to 0.2 divided 1 to convert into kilogram, and using this mass to multiply this number 2 times 10 power 10 at the power negative 4, okay, equal this number. Okay, the correct answer is C. This is the true answer. Calculate the amounts of energy produced from the transformations of 5 gram of 1 joule 2 million electron volt. This is the questions. Okay, you must take a transfer gram into kilogram. 5 over 1000 equal to 0.005 kilogram, and use this number 0.005 times 3 times 10 power 8 power 2. So this is a number by joule. You can to convert it into M times 931 you can this conversion by using this number to convert it into million electron volt, or you can using this this number converted into million electron volt. Now we will finish the question in this last slide, and I will to understand this good. Now I have what is the mass in kilogram requires to produce an amount of energy equals 190 million electron volt. I have many choices, must write it and to calculate it. Idea of answering now 1 million electron volt equal to 1.6 times 10 power negative 13. 190 million electron volt, which equal crossway. So this is a known number equal to 190 times 1.6 times 10 power negative 13 over 1. So this is the value. Now we finished for the last things, and the next session will start in binding energy to complete this lesson. Now, thank you for good listening for our session. I will see you in the next session, inshallah. Wassalamu alaikum wa rahmatullahi wa barakatuh.